It all started with a peculiar reading from the Martian surface, one that, at first glance, didn't seem like it would rewrite history. NASA's Perseverance rover, steadily exploring the Jezero crater, had spent over a year collecting samples and transmitting data. Outfitted with the most advanced suite of tools ever sent to another planet, it had already provided striking evidence of ancient riverbeds and geological formations. But its latest discovery would ripple through the scientific world and beyond. Buried beneath Mars' iconic rust-red dust, where ancient winds once etched canyons into what used to be lake basins, the rover made a find that was not just strange, it was paradigm-breaking. A finding so unsettling, so potentially historic, that it might redefine how humanity sees its own place in the cosmos. Before we dive deeper, don't forget to hit the like and subscribe buttons for more mind-blowing updates. During one of its routine spectrographic scans of a clay-rich ancient deposit, Perseverance detected a peculiar chemical fingerprint. At first, it appeared to suggest complex carbon-based compounds, unusual but not unprecedented. However, upon further inspection, something far more compelling emerged. Microscopic structures embedded within mineral deposits, displaying unmistakable characteristics of microbial colonies. These weren't simply organic molecules like those found in earlier missions. They were arranged in ways that strongly suggested biological origin. Whether fossilized or long dormant, their design hinted that they had once been alive. The implications were nothing short of revolutionary. For decades, Mars was believed to be sterile, devoid of life. But now it had revealed a secret it had kept hidden for billions of years. It might have once hosted living organisms. These tiny formations were no random patterns in stone. Their symmetry, spacing, and orderly distribution followed patterns strikingly similar to microbial growths on Earth. Even more revealing, these structures were sandwiched between clearly datable sediment layers, ones that originated more than 3.7 billion years ago, when Mars was warmer, wetter, and wrapped in a thicker atmosphere. It wasn't a coincidence. This potential biosignature came from the one window in Mars history when life, if it ever existed, could have thrived. What made it even more shocking was their chemical makeup. Using high-precision X-ray diffraction and Raman spectroscopy, the rover examined their internal bonds. What it uncovered exceeded even the most optimistic expectations: fragments of amino acids, and what appeared to be the early formations of proteins, locked within magnetite and sulfide matrices. These are substances on Earth frequently tied to microbial activity. In other words, this wasn't just possibly biological, it could be a window into a second genesis. For years, scientists had speculated that life could evolve separately on different worlds. Now, that idea wasn't just a theory. It might be confirmed. If Martian life truly developed independent from Earth's, then life might not be an anomaly. It could be the rule, springing up wherever the right ingredients come together. This single discovery didn't just challenge the idea of Earth's uniqueness. It shattered it, and that realization sparked a tidal wave of new, profound questions. Could life exist elsewhere in our solar system? Beneath the ice of Europa? Deep within Enceladus? And most urgently, what became of Mars life? The site showed no signs of modern activity. No tremors, no shifting geology, meaning these structures hadn't been displaced by some external force. They remained exactly where microbial life might have grown, by an ancient shallow lake, bathed in sunlight, rich in nutrients. This wasn't just a fluke. The environmental conditions were ideal, just like Earth in its early years. Mars hadn't just mimicked Earth's life-harboring recipe. It had followed it. This brought a serious dilemma to the forefront. If Mars once supported life, even at a microscopic level, how should humanity proceed? Could future missions contaminate a once-living world? Should we rethink how we approach Mars entirely, ethically and scientifically? A human footprint might destroy what remains. Even an unintended trace could render future research inconclusive. Suddenly, Mars wasn't just an exploration target, it became a sacred site, a biological relic, a cousin world that deserved respect. On the scientific side, the findings had another layer of promise. The makeup of these samples hinted at extremophiles, life forms that thrive in the harshest of environments. If true, it meant Mars might still shelter life underground, where warmth from its core may linger. This discovery supported the idea that life doesn't arise from randomness, but from consistent planetary chemistry. Life might be what happens when conditions are simply right. Within those sediment layers, isotope readings revealed something even more intriguing. The carbon exhibited a preference for lighter isotopes, a known biosignature on Earth. This pattern wasn't typical of inorganic processes, pointed yet again toward a biological origin. Some of the mineral shells encasing the formations displayed textures consistent with biofilms, slimy layers formed by microbial communities on Earth. Such traces are often the earliest indicators of life, preserved in our oldest rocks. Mars had now joined that ancient register. Perseverance's high-resolution imaging system delivered stunning visuals. Thread-like strands entangled with tiny spherical clumps, networks eerily familiar to scientists. It looked like life's final gasp had been captured in stone, undisturbed for eons. The imagery wasn't abstract or speculative. It was clear, silent evidence. Mars had once breathed. And this wasn't a one-time fluke. As the rover carefully advanced across the crater, more formations were found, some larger, others fragmented, hinting at once diverse ecosystems. They were widespread, not isolated, turning this discovery from a miracle into a new Martian norm. Even more astonishingly, atmospheric sensors detected faint traces of methane and hydrogen sulfide, gases usually associated with microbial activity. Their concentrations were low, but they consistently coincided with the areas rich in the microstructures. It was as if Mars was still whispering its past through chemical traces. In the blink of an eye, the scientific landscape changed. Entire disciplines, astrobiology, planetary science, evolution, even philosophy, needed updating. New models emerged to explain how life adapts and spreads across worlds. If life began separately on Mars, could it be even more common across the galaxy than we ever dared imagine? One revived theory stood out: panspermia, the concept that life can jump between planets, hitching rides on meteorites. Could Earth's earliest organisms have come from Mars? Or vice versa? The boundaries between Martian and terrestrial life began to blur, possibly tracing back to the same cosmic root. This revelation reached far beyond biology. It touched belief systems, challenged humanity's core assumptions, and redefined what it means to be alone, or not alone, in the universe. Those microscopic fossils, or what most now agreed were fossils, stood as silent monuments to a planet that once thrived. A world that may have dreamed, struggled, and perished in silence. And now, through science, we had begun to listen. NASA's goals had changed overnight. Those samples, once destined to be mere geological specimens, had become artifacts, sacred relics. Their transport, study, and containment would be handled with care and reverence, more like ancient texts than dirt and rock. Global research teams braced for the most anticipated lab studies in human history, prepared to look 3.7 billion years into another world's past. And in the hushed silence of Mars, once mistaken for finality, humanity heard a whisper of something more. Mars was no longer a distant, dead rock. It had become a mirror, a reflection of our own origins, our own questions, and the endless possibilities scattered across the stars. If you found this video fascinating, be sure to hit the like button, subscribe to our channel, and share your thoughts in the comments. What do you think about NASA's stunning Mars discovery? We'd love to hear from you. Thanks for watching, and we'll see you in the next one.